Problem number 2, objective 1. Two cars having masses m1 and m2 move in circles of radii r1 and r2 respectively. If they complete the circle in equal time, the ratio of their angular speeds omega 1 by omega 2 is. Do you know the relation between time and angular frequency? Do you know?
Yes, sir.
Yeah, tell me.
So time is equals to 2 pi by omega.
Yes, correct. Very good. So that's it. You use that T1 is equal to 2 pi by omega 1. T2 is equal to pi by omega 2. They have given T1 is equal to T2. So if you do that, if you take that 2 pi by omega 1 is equal to 2 pi by omega 2, and we want omega 1 by omega 2, that is equal to 1. That's it. That is the relation. That's it. T is equal to 2 pi by omega. According to that, omega 1 by omega 2 is equal to 1. The next, third problem. A car moves at a constant speed on a road as shown in figure. The normal force by the road on the car is Na and Nb at points A and B. Okay. At point A, normal force is Na. At point B, normal force is Nb. The car is moving actually at a constant speed on that particular road, this kind of road. Okay. So they are asking the relation between Na is equal to Nb or Na and Nb. So you should draw a free body diagram at A point, at B point. Then you can find out normal forces. If you draw free body diagram at A point, normal force upwards in A, okay, and weight downwards, mg, and there is also, it is, since it is a curved path, and there is also one more force called centripetal force. So centripetal force, the mv square by r, has been provided by the frictional force. So mv square by r will also be there. And at NB, RA, let us talk about. Okay, RA, because here radius of curvature is different, here radius of curvature is different. For B also, same NB upwards, and mv square by RB, mv square by RB upwards and downwards mg. Okay. So if you write the equation, net force equation, mg is equal to Na plus mv square by Ra, or mg is equal to, from second free body diagram, mg is equal to nb plus mv square by Rb. So from first free body diagram, Na is equal to mg minus mv square by Ra. Okay. Then nb is equal to what? Tell me. nb is equal to what? Don't know? Don't know this answer? NB is equal to, you cannot do?
Sir, M of G minus V square by RB.
Oh, it's okay, fine. Yeah. NA is equal to mg minus mv square by RA. NB is equal to mg minus mv square by RB. So mg is same in both the equations. M is same in both the equation. V is same in both the equation. The only difference is RA and RB. If RA is more, the mv square by RA value is less, and mg minus mv square by RA is more. If RB is more, mv square by RB's value is more, and mg minus mv square by RB is less. Okay. So here we can see RB is more. Radius of curvature for a B hump, B curve, B turn is more. So NB is less value. You will get NB as less value. Okay. And here very important point, this mv square by r we will take as a convention away from the center. Away from the center. This is actually centrifugal force. Okay. Centrifugal and centripetal both are equal only. Both are equal. And as a convention we will say mv square by r outside only. Away from the center. Okay. So the answer is Na greater than Nb. The answer should be Na greater than Nb. Okay. Is it okay or any doubt? Wait. Na is greater or Nb is greater? 1 minute. If Ra is greater, Na is lesser. If Rb is greater, yeah. Actually, RB is greater. RB is greater, yes, no. Curved path, RB is greater, yes. So, these are the two equations. So, RB is greater actually. RB is greater means mv square by RB is lesser. So, mg minus less value will be NB is greater. Yes, NB is greater. Option C is the answer. Option C should be the answer. Okay. Did you understand?
Yes, sir, understood.
Fourth question. A particle of mass m is observed from an inertial frame of reference and is found to move in a circle of radius r with a uniform speed v. The centrifugal force on it is centrifugal force when is seen from inertial frame. That is mv square by r towards the center, mv square by r away from the center, mv square by r along the tangent to the particle, or 0. What is the answer? Centrifugal force is a pseudo force. Okay. Centrifugal force is a pseudo force. And pseudo force will only exist when it is seen from non-inertial frame. Okay. So they have clearly mentioned it is seen from or it is observed from inertial frame. So pseudo force will not be there with respect to inertial frame. Okay. With respect to inertial frame, pseudo force is 0. That means centrifugal force is 0. With respect to non-inertial frame, if we talk about, option B can be the answer. mv square by r away from the center with respect to non-inertial frame. Okay. See here, non-inertial frame means with respect to the body which is moving in a circular motion path. That is called non-inertial frame. Okay. Inertial frame means outside the circular motion, who is there? That observer. He is on the earth. So with respect to him, that is an inertial frame. Okay. So this kind of example we have already done. That washing machine example. Washing machine drum. Along with the drum, if it is seen, that is a non-inertial frame. And the observer who is washing the clothes, it is an inertial frame. Okay. So why there is a difference? Because it is moving with some other acceleration. When you talk about circular path, circular motion body, with respect to the body which is moving in circular path, that is actually moving another acceleration with the earth. Okay. What is the definition? Definition is that only, no? Non-inertial frame means it should travel with any other acceleration as that of earth. That is why it is considered as non-inertial frame. And outside observer means he is in touch with the ground, so he is an inertial frame. The next, fifth question: a particle of mass m rotates with a uniform angular speed omega. It is viewed from a frame rotating about the z-axis with a uniform angular speed omega naught. The centrifugal force on the particle is. They are just asking the expression of centrifugal force. You know the expression. What is the answer? Direct question. This is direct formula of centrifugal force they are asking. What is the answer?
Sir, m omega square.
Yes, very good. Excellent. Excellent. M omega square or m omega naught square. That is number one. That we have to keep it in mind. But you have come close to the answer. Okay. The option like centrifugal force is mv square by r or mr omega square. This is the like expression for centrifugal force. Okay. But m omega square a or m omega naught square a, that we have to focus. A particle of mass m rotates with a uniform angular speed omega. It is viewed from a frame rotating about the z-axis with a uniform angular speed of omega naught. Okay. So we have to consider the frame which is out of which we are observing. Okay. It is viewed from a frame rotating about the z-axis with a uniform angular acceleration speed omega naught. Okay. So option B should be the correct one. M r omega square is the general expression. Instead of r, they have given a. That's it. So m a omega square. That is the general expression. But here it is viewed from the another frame which is from omega naught. So we have to take it from omega naught only. Option B is the correct answer. Okay. Is it okay? May I go for next question?
Okay, sir.
Next, sixth one. Here you have to do some simple mathematics. A particle is kept fixed on a turntable rotating uniformly as seen from the ground. The particle goes in a circle. Its speed is 20 centimeter per second and acceleration is 20 centimeter per second square. Okay. The particle is now shifted to a new position to make the radius half of the original value. Okay. So what they are doing is, this is the circular motion, the turntable we can say. First, the body is moving, let us say, the body is moving at a radius r. Okay. This is the first location, this is the first case. And second case, this is r by 2, radius is r by 2, half of the radius. Okay, turntable is rotating. First we kept the object at r radius and it is rotating. And when it is rotating, its speed is 20 centimeter per second, acceleration is 20 centimeter per second square. When the r is half, r by 2, then what is the speed and acceleration? That is what the question is. Okay. So you try using, we have various expressions like centripetal the acceleration is v square by r and speed is v by r, something like that. So there are many expressions. You try that. Use the expressions v square by r as for centripetal acceleration and v by r for angular velocity, and then try to find out the radius. Okay. Then you divide the radius by 2. Then once you get the radius, then you can find out again speed and acceleration. Okay. So first step, what do you do? Use the centripetal acceleration, that is v square by r formula. V square by r formula. A is equal to v square by r. A is given, v is given. R you find out. A is given, v is given. R you find out. What is R? Let me know. When you substitute A is 20, V is 20, you will get radius as 20. They have asked half of the radius. So radius will be 10 centimeter. Next case. Okay, radius should be 10 centimeter and you should know speed and acceleration. So speed is equal to V is equal to R omega. Actually, V is equal to R omega. We know R as 10 centimeter, but omega we don't know. If you know omega, then you can get the speed. Okay. So the formula is V is equal to R omega. I am taking W actually. Here I cannot type. V is equal to R omega. We need omega. Omega is equal to V by R. From the first data, Omega is equal to V by R. V is 20. We got. No, they have given 20 and radius also 20. We got. So that is equal to 1 radian per second. So this 1 radian per second, you substitute in this formula V is equal to R omega, you will get a speed. What is the answer for speed?
Sir, V is equals to 10, na?
Yes, correct. 10
Sir,
centimeter
V
per
is equals
second.
to 10.
Correct.
Sir, 10 centimeter per second or 10 radian per second?
No, no, no. See, that is what very important. V is a linear speed. I have already told. S,
Okay, sir.
P,
Okay, sir.
A, they are linear speed. So centimeter per second it should be. And if you talk about
Okay, sir.
omega, that is radian
They
per
are
second.
angular.
Uh,
Yes, sir.
Theta is angular, omega is angular, alpha is angular. So there you will get radians. So omega you got it as 1. Then V is equal to R omega. Again you use R is 10 and omega is 1. So V is equal to 10 centimeter per second. Okay. And A is equal to what? Formula R omega square. Use that. That's it. You will get the answer. A is equal to R omega square formula.
Sir, 10 centimeter per second only, no?
That's it. R is 10, omega is 1. So 10 centimeter per second square. Is the answer. Option A. Option A. Yes, correct. You should know the relation between linear speed, angular speed, linear acceleration, angular acceleration, or angular linear velocity. Like V is equal to R omega, A is equal to V square by R, this kind of relations. These are basic fundamental in circular motion, compulsory you should know. And equations of motion also you should know.
Sir?
Yes.
Sir, can you explain the how A will come, sir?
Hmm. A is R omega square formula. A formula is R omega square. R is reduced to 10. So 10 into omega is 1. 10 into 1 square, 10 only. Na? Okay. Is it okay?
Okay, sir. Due to signal problem, I didn't hear you, sir, when you were saying.
Screen is blood, sir. Can you screen share again?
Okay. I'm sharing again. Water in a bucket is whirled in a vertical circle with a string attached to it. The water does not fall down even when the bucket is inverted at the top of its path. We conclude that in this position, so what do you say? Mg is equal to mv square by r, or mg is greater than mv square by r. Mg is not greater than mv square by r. Mg is not less than mv square by r. Okay. So what they are doing is, in a bucket you are mixing the water, boiling. You are making it to circular motion. Water. Okay. Then there again a vertical circle with a string attached to it. Okay. You are rotating it, and water inside the bucket is like making a circular motion. Okay. then water is inverted. Bucket is inverted. Bucket is inverted at the top of its path. Okay. So we conclude this that in this position, what happens? So what do you think? Like water will fall down, but something happening, some other forces are dominating or something happening, so that water is not falling down. So what could be the reason? What could be the reason? Sorry. Sahasra's answer is mg is less than. See, downwards mg is there and upwards mv square by r is there. Okay. So if mg is greater, the water should fall.
Water will fall.
But water is not falling. That means mg is lesser. mg is lesser than mv square by r. That is correct answer. But again, they have given the option in a tricky manner. mg is less than. Instead of that, mg is not greater than they have given. So option C should be the answer. mg is less than mv square by r, or mg is not greater than mv square by r. This is the answer. Very good, excellent,
Okay, sir.
Sahasra. Good.
Stone is rotated and thrown.
Question number 8. A stone of mass m tied to a string of length L is rotated in a circle with the other end of the string at the center.
String breaks, the stone
The
will move
speed
away
of the
from
stone is v. The string breaks, the stone will move. Yes, away from the center. Along the tangent, it moves along the tangent. If string breaks, it moves along the tangent. It continues its direction along the tangent, not from away from the center or towards the center.
Okay, sir.
Because along the tangent, its velocity, its acceleration directions are there. So that's why when it is cutting towards it maintains its velocity direction. The next question. Ninth, coin is placed on a rotating turntable, just slips if it is placed at a distance of 4 centimeters from the center. If the angular velocity of the turntable is double, it will just slip at a distance of. How to do this? Any idea how to do this? If the angular velocity of the turntable is double, it will just slip at a distance of. So it just slipping. In both the cases, just slipping. That means the force required in both the cases is same. That is the concept. Whether it is 4 centimeter with some omega acceleration or with some other this with some other like 2 omega angular velocity at some other distance. In both the cases, the force required should be same. That is the main fundamental. Okay, so you equate the forces in both the cases. Like first case, in terms of angular velocity, force equation is mr omega square. In the second case, mr, it is doubled, omega is doubled, so it will be mr into 2 omega whole square. Okay, and you simplify, you equate those two expressions, simplify, you will get the answer. Yeah, so mm gets cancelled, r1 is 4, r2 is, you have to find out, omega 1 is omega, omega 2 is 2 omega. That's it. Yeah, 4 gets cancelled, and omega 1 square gets cancelled. So r2 is equal 1 centimeter. Yes, correct answer. The option is A. Option A. The next question. A motorcycle is going on a overbridge of radius r. The driver maintains a constant speed. As the motorcycle is ascending on the overbridge, the normal force on it. The motorcycle is going on an overbridge of radius r. The driver maintains a constant speed. Okay. As the motorcycle is ascending on the overbridge, the normal force on it increases, decreases, remains same, fluctuates. What is the answer?
8 to 8:30.
Huh? It will increase or decrease or same. So simple thing. See, for friction, how we have solved different free body diagrams. Na? In the same way, for in the circular motion also, you should know free body diagrams at various positions. Like at this position, you should know. At this position, you should know free body diagram. At this position, we should know. At this position, we should know. Okay. And if you know these free body diagrams at every position, you can do most of the problems easily. Okay. So here free body diagram is mg is downwards, normal force upwards, mv square by r is upwards. And here free body diagram is normal force upwards, mv square by r downwards, mg downwards. That is very important. And here, so it is ascending. They have given that it is ascending. So somewhere here, it is not at the highest peak point. It is here. Okay. So weight component will be mg cos theta. It is not mg, it is mg cos theta. Okay. A normal force upwards. And mv square by r is also upwards. Okay. So now you can tell normal force is equal to what? Mg cos theta minus mv square by r. Mg cos theta minus mv square by r. Okay. So as it is moving up, theta is gradually increasing. As it is moving up, theta is gradually increasing.